Hello, Algebra 2. We are now starting our unit in rational functions. This is the video key for our first lesson in that unit, which is 8.1, and we're going to be talking about excluded values and domain. Here's number 1. We are given the rational expression 10 over 4k minus 10 and asked to find any excluded values. And when we're talking about excluded value, we're talking about any value that's going to make this fraction undefined. And how do we get an undefined fraction? That's when our denominator equals 0. So the simple way to find excluded values is just set our denominator equal to 0. So we'll have 4k minus 10 equals 0. And now we just need to solve for k to find out what that excluded value is going to be. We add a 10 to each side. We'll get 4k, these cancel out, equals 10. And then we're going to divide each side by 4, and we get k equals 10 fourths, or we can simplify that down to k equals 5 halves. So in this case, our excluded value is 5 halves. Number 2, we're given the rational expression x squared minus 6x plus 9 all over x minus 3 and asked to find the excluded value. And to do that, we set our denominator equal to 0. X minus 3 equals 0. So we just solve this for x. Add a 3 to both sides. X equals 3. Our excluded value in this rational expression is 3, or that's the number in which case this expression would be undefined. Here's number 3, n squared plus 5n plus 4 all over n plus 1. To find the excluded value in this expression, we just set our denominator equal to 0. So n plus 1 equals 0, or n equals negative 1. Negative 1 is the value that's going to make this function be undefined, because that's the value that's going to make the denominator 0. So our excluded value is negative 1. Number 4, we're given the expression x squared plus 2x minus 15. That is all over x plus 5. To find our excluded value, we look for the value that's going to make this undefined. And when is this undefined? When our denominator equals 0. So let's set this equal to 0 to find what that excluded value is. X plus 5 equals 0. Subtract 5 from both sides. X is negative 5. That's when this value will be 0. So there is our excluded value right there. So in number 5, and actually starting with number 5 and moving through the rest of the homework assignment, we're asked to find the domain. So when the first 4 problems, we were finding excluded values, and those values were excluded from what? What were we excluding those values from? Well, we are excluding them from our domain. So our domain is going to be the set of all real numbers, not including our excluded values. So that's why we went through the exercise of finding the excluded values. So now when we're looking for our domain, it's going to be all the real numbers except for the excluded values. So we're still going to set this equal to 0. 2x squared minus 8x equals 0. What we want to do is we want to factor out the greatest common factor here. So the coefficients, it'll be 2. The variables, it'll be x. If you're a little rusty on that, go back to our lesson on greatest common factor. Get some more practice on that. But pulling the greatest common factor of these two terms is 2x. And when we pull that out of the expression here, we're left with x minus 4 equals 0. So now we just set each one of these equal to 0. So 2x equals 0, or x minus 4 equals 0. So we'll be left with our excluded values will be 0 and 4. So our domain is going to be all real numbers except for 0 and 4. So I'm going to write that up in the corner here. Those are our 2 excluded values. So when we write our domain, we write it in set notation. So we're going to have it inside these brackets. Okay. So we write all x's, and this is, you put that little bar in there. What that bar means is the word such that. X does not equal 0, 4. So what this means, this is a set of all x's such that x does not equal 0 and 4. And that's our domain. That's basically all the x's values that we could put in this expression and it come out with a defined answer. The only time it's going to be undefined is when our denominator equals 0. And the only time that's going to happen is when x equals either 0 or 4. So those are excluded values. So again, this reads all x values such that x does not equal 0 or 4. And that is how we write the domain of this expression. Okay, here's number 6. We're given 6r plus 2 over 10r squared. So we define our excluded values, which means we're setting this equal to 0. 10r squared equals 0. Well, what's going to cause, what value of r will cause this to equal 0? That's when r equals 0. So we know our excluded value is 0. So we'll put that in our set notation. So it's all r's such that r does not equal 0. And we'll close the bracket on the end there. So that is our domain in set notation. Okay, here's number 7. We have 4n minus 8 over 10. So what's our excluded value here? What values of n will make this denominator equal 0? There aren't any. You could put any value in there for n and our denominator will never equal 0. It's always going to equal 10. So how do we write that? We can write it two different ways. We can write all real numbers. We could write that as set notation. Or you could write r is in the set of all real numbers. Okay. What this means is r is an element in the set of all real numbers. This little term here, which is an r with two lines on the left, that means all real numbers. So if you can remember this notation, great. But you can always just write all real numbers inside brackets in here as well. Let's look at number 8. We have 9x minus 12 over 9x. What are our excluded values here? Well, those are the values going to make our denominator equal to 0. So I'll just set it up that way. 9x equals 0. Divide each side by 9. And I get x equals 0. That's the value of x that x cannot be. As soon as x is 0, that makes our denominator 0, which makes our expression undefined. So our domain is going to be x such that x does not equal 0. And there's our answer for number 8. Okay, here is number 9. We have k squared plus 8k minus 9 all over 10k plus 90. What is are we going to find our excluded value? We're going to set our denominator equal to 0. So 10k plus 90 equals 0. Subtract 90 from each side. We get 10k equals negative 90. We're going to divide each side by 10. And k equals negative 9. That's our excluded value. K can never equal negative 9. When k does equal negative 9, that's going to set our denominator equal to 0 and make our expression undefined. So how do we write this? We'll put it in brackets. So it'll be all values of k such that k does not equal negative 9. And that's how we would write that in set notation. Here's our final question for 8.1. Question number 10 reads 8 squared plus 7a minus 18 all over 8 squared plus 14a plus 45. We need to find our domain here. So first we need to find our excluded values, and to do that we're going to set our denominator equal to 0. So a squared plus 14a plus 45. And what we have here is a trinomial we have to factor. So during rational expressions, yes, factoring comes back, the AC method comes back, difference of squares, sum of cubes, difference of cubes, that'll all come back. So find those old notes and dust them off, or find them back in those lessons in Google Classroom because they are coming back. So right here we have a trinomial. Our leading coefficient is 1. So that's going to work much like one of those diamond problems. If you remember, we looked for two numbers that we multiplied together to equal 45. and when we add together equal 14. So skipping over all that, because we've been through this unit before, it'd be 9 and 5. So a plus 9, a plus 5. That is factoring our expression here. We're going to set that equal to 0. So when are these going to equal 0? Well, when one of these terms inside the parentheses equals 0. So we'll set a plus 9 equal to 0 and a plus 5 equal to 0. On this side, we get a equals negative 9 or a equals negative 5. There are our two excluded values. When a is equal to negative 9 or a is equal to negative 5, that's going to cause the denominator here to be equal to 0. We can't have that because the denominator equal to 0 makes the whole expression undefined. I can write that off in the corner up here, negative 9 and negative 5. So now when I write this domain in set notation, let's start with the brackets, and it's going to be a such that a does not equal negative 9 or negative 5. And there is our answer to number 10. So hopefully working through all 10 of these helped you understand excluded values a little more and how that plays into finding the domain and then finally writing the domain in set notation. If you still are stuck on some of the problems or still having an issue working through some of them, please email me and we will work through those together.